Let's solve problem E. So, in this problem, first, what you understand is you need to find the minimum and maybe somehow convert all of the numbers to the minimum. There's an exception that sometimes we don't touch the numbers that are minimum plus 1. So, let's say we have three types of numbers: minimums, minimum plus 1, and others. For others, we will for sure convert them to minimum. For minimum plus 1, it doesn't matter, and minimum is for sure minimum. So first, why we don't touch minimum plus 1s? Because when we want to convert some minimum plus 1 to minimum, we need to at least spend one cost, and actually we reduce it by 1 and it isn't effective. But also, if we do that, it's okay. So minimum plus 1s, they are just okay. We may convert them or may not. But about minimum plus 2s or more, the thing is, for sure we can find some near minimum that it benefits that we converted to minimum. So actually, I'm gonna jump into the code directly and cover all of the details there because it's not that hard problem. It needs a lot of observations and taking care, but I think the solution I have would be straightforward and goes to AC easily. Let's see. So let's start this cleaning up the code we had. And then let's define our array like this, and then doing a for loop like this, and getting the input like this, and finding the minimum min element of a what? Then let me define an enum state, which is either fresh, take, or skip. So what does it mean? Fresh means the fresh start, like we didn't see any elements, or yeah, we can consider that we didn't see any elements. Take means that we are taking some elements that are more than strictly more than minimum plus 1, that we need for sure take them. And skip has another meaning. So consider the case: we have some elements with in the third group. So let's say we have three types of integers: minimums, minimum plus 1, and others. So group 1, group 2, and group 3. So consider we have some elements of group 3 here, and then a single element which is minimum, and then some other elements of group 3. Note that we are completely ignoring the group 2. We just skip them, you'll see, because they just don't matter. If we take them or we don't take them, the result is the same. Even we can remove them from the array completely, so we can have only group 1 and group 3, that's it. So continue with me. What we have here is so we have some elements of group 3, then some single element minimum, and again some elements of group 3. What do you think? We should pick the minimum and also both groups at the left and right with this element, and this will reduce the cost. But in some cases it doesn't happen. So like, let me come with some example for you. So what I was telling you was something like this. In this example, we will take the whole group, so the group 3 here and this minimum and this together, that's it. But consider this one. So for this, we don't pick all of these things, right? We pick this, and then we pick this. So skip means that we just saw a minimum after a group of three, after a group of three. So it means that we are just ready to skip this group. So by skipping this group, we know that they are already included in this, in the range that this will make all of them minimum. So we'll start with a fresh start and loop over all of the elements, and we'll see what happens. So it's just a lot of ifs here. So if AI is more than mn plus 1 and this is fresh, this will become take. And let me tell you that for sure we'll have n equals to mn times n. That's clear because everything will be reduced to mn. We can consider that. So then if AI is mn plus 1, just plus n's, nothing else. Convert as to take in this case. And also we need to add 1 to n's y because this needs a range that comes and fix this minimum for sure. This will be converted to fresh. So what about others? If s is take, it remains take. If s is skip, it remains skip. So that's it. Else we know that it's mn. Then if s is take, we will add 1 to n's because this just happened after a group of 3, and we'll turn it to skip. Else if s is skip, we will turn s to fresh. And what if s is fresh? If s is fresh, we'll don't change it, that's it. And finally we will add to n's if s is take. We need to add another range for this, so another minimum for this. And this is the other case, and let's see, right? So let's see, 3 and 13, that is correct. Let's check everything. Everything looks good, looks good, looks good. Let's submit. Let's submit problem E like this. Where are my submissions? You see, right? We submitted for B and C, and we had a lot of submissions for other problems. Where are they? So yeah, as you can see, it's testing contest, so everything can happen. And it's in queue. Okay, I will pause the I will pause recording and come back when the verdict is determined. Okay, I got wrong answer, and I think I know why this is happening. It says that r minus l, not r minus l plus 1. And as you can see in the sample test cases, you don't need to apply any operation. So that's why it's printing correct answer for them. So fixing this seems easy. So for each operation I do, for each salary I choose and want to do this operation, actually I need to decrease the answer that I'm adding by 1. So first I should remove this, because consider a range at the end. we don't need to, we want to just add answer by what we were adding, but -1, so removing that will work. And for others, my idea here is not adding to answer. In this case, the only case for the very first bit, very first element, we don't count. And let's try some example to see if it's working or not. So 2, very simple, 3, 1. To make it better, let's have this. It should print 1, right? Correct. And even if I do this, it should print 1, correct. And if I do this, it should print 2, which is correct. And for this, it should print 2. It should print 2, right? So in this case, I need to revert it back because I didn't count it at the beginning. So if s is take at 1, so now it should print 2. It should print 2. My bad. It prints 2, and that's working. Let's submit again and we'll think more. So basically I'm just skipping the first element of each group. That I think it should work. But let's submit and see what happens. But let's think about if with this new constraint we can make even easier solution. What do you think? So there are some elements that we want to add, and finally, why this page is not loading? Okay, fine. I think Codeforce is experiencing some problems. I'm not sure it's gonna judge my code very soon again. Yeah, it has a very long queue. No, running. Let's see. Okay, it's going. It's still going. So this is like for big integers. We can have 1, and then we can skip that minimum that we select. So it seems that we just need to count the numbers. That seems a bit interesting. So give me a second here. Maybe this will work. I know that it's crazy, but it seems that it's working. Is this new definition? It seems that it's working. Plus so we can just print. So let's remove all this, remove all this, and just plus n minus count of a plus n and mn. Let's print, and let's. This will work for sure in this sample this case, but let's submit again. It was nice. It's very nice if it gets AC. Yeah. So as you can see, just 20 lines of code. Even less, like 10, and we got AC. That's it for problem E.
Thanks for watching. If you found this video useful, please like, subscribe, and ring that bell. By the way, YouTube thinks the video down here is just perfect for you. Give it a watch and let me know in the comments.